All right, welcome to, what is this, 9.3 notes. You'll be able to hear me, you'll be able to see everything else. I'll be back in the background doing this. But to understand that you're going to get this day and the next, the 0.3 and the 0.4 notes via this, via a video. Hopefully you have a great spring break. And I will see you when I get back on the 24th of March. All right, so let's get started. You're doing 9.3 notes, area and perimeter of triangles on the coordinate plane. All right, we want to analyze rectangle ABCD. And what is the formula for area of a rectangle? Well, you guys have always seen it as area equals length times width. And that's what you guys have always seen. Now, here at this level, we're going to change it slightly because it'll work for all quadrilaterals. And that is, instead of length, we're going to talk about its base. So we're going to use the word base. And then width, we're still going to use, well, let's use height for that. So we will talk about base times height. And we're going to use that kind of formula and those words throughout this. We use them with parallelograms. We use them with all quadrilaterals. We use them with the trapezoids and kites and all that. Okay? So, the next part of this says draw the diagonal AC, and what does this do to the figure? So if I draw a diagonal from A to C, so if I take A and I go to C, something like that, and I draw that right there, what did I do? Well, that line segment AC, a solid bar over the top of the two letters AC, that means line segment. Well, that line segment AC is cutting, or it cuts, rectangle ABCD in half. And in essence, what did I do? I created two congruent triangles. I created two congruent triangles. And I know, now the next part of this, and it says, and I was getting ready to say I know, but remember these are two triangles, and more importantly, they are right triangles. And we learned this because we know that the angles of a rectangle are 90 degrees. So these are in essence two right triangles when I use that diagonal. Now the next part says use the information from questions A and B to develop the area of a triangle. Well, if I know that the area of the rectangle is base times height, I know that from there, I know that I cut this rectangle in half, right? So if I cut it in half, what do I know? Well, I know that if I simply cut it in half, then the area of one of these triangles is going to be 1/2 times base times height. And I'm just abbreviating the B and the H to be B for base and H for height. Now, the other way I could write that is simply B times H divided by 2. And it works either way. 1/2 times base times height or base times height divided by 2. And at the end of the day, this is the equation for the area of a triangle. So the area of a triangle is always going to be 1/2 base times height. Okay? All right. Going up. It says graph triangle ABC with vertices -7.5, 2, Negative 5.5, 13 for B, and C is at 2.52. And we want to determine the perimeter of triangle ABC. So we know we're going to find perimeter, so I know that I'm going to be finding perimeter. I'm just kind of giving that my idea over there. And it says round to the nearest tenth. Round to the nearest tenth, so we can do this in decimal form at the end. We want to leave things as we want to leave side lengths as radicals as we do this, though. We don't want to round until the end. Okay, and that's what it's telling us. Okay, we can round to the nearest tenth at the end. We want to leave in just radical form until then. All right. So let's do this. Let's go ahead and plot our points. Negative 7.5, 2. There's 7, 7.5, up to 2. Should be right there. Right there. And B is at negative 5.5, 13. So negative 5, 5.5, all the way up to 13. And this is counting by 2. So there's 12. There's 14. So right in here, right there. So this is my B. This is my A. And C is going to be at 2.5, 2. So 2.5 up to 2 right there. And that's going to be my C. All right, let's connect those dots. Make our triangle. Good. And one of them kind of moved on me. So let's do this. Rewrite it. There we go. Well, it really does not want to stay, does it? All right, let's try it on the outside part of it. There we go. That's closer. All right. So there's my A, there's my B, and there's my C. Now, you're going to notice I made a mistake. I said negative 2.5, 2, and it is actually 2.5 and not negative 2.5. So my actual point is out here. I was hoping someone would catch that. We didn't, and I didn't until this part. So now I'm going to go ahead and go this way, and then I'm going to go this way. And the reality is it's out there. I'm glad I caught that, or I would have been looking a little funky as we did this. All right, so there's my points. Negative 7.5, 2, double checking. Negative 5.5, 13, and 2.5, 2. All right, we got those. Now it says determine the perimeter of these. Well, there's one of these I can count. And I can look from A to C. The distance from AC should be countable. It should be 10. And I look at that, and how do I know that? Well, if I go from negative 7.5 all the way to 2.5, 7.5 to 2.5, that is 10. So I can do that one by counting. It is a horizontal line. So this is going to be 10. Now, looking at A, B, and B, C, I can't find distance by counting for these. So I must do the distance formula. So here we go. I want to find the distance of AB. So I'm going to take the square root of x2 minus x1 squared plus y2 minus y1 squared. Remember, by the time we're done with this unit, you should have written the distance formula 57 times. You should know this. Every time you should write it, you will know it by heart. Well, A is at negative 7.5 and B is at negative 5.5. So I'm going to put in the negative 7.5 here minus the negative 2.5, or the 5.5, as I said that, minus 5.5, and I'm going to square that, and then my y2's are going to be 2 minus 13. And when I look at those, I know a negative and a negative make a positive, so I have that one. So when I see this, I see that this is going to be a negative 2 squared plus, this is going to be a negative 11 squared. And I know that AB is then going to be 4 plus 121. So this is going to be the square root of 125. And right now I know that the square root of 125 is not a perfect square. And remember, it says leave side lengths as radicals. I'm going to leave it as the square root of 125. Now I also need to find the distance of BC. So I'm going to do that right now. You're going to see me erase all of this for AB because I don't have the room. Basically writing on this iPad, I don't have the room. So you're going to see me erase BC or the AB so I can put up BC. So please make sure that you pause this if you need AB, and then you can unpause it and then do BC right below it. You should have plenty of space in this part right here for you. Alright, so I'm going to do BC now. So B to C, once again, the square root of x2 minus x1 squared plus y2 minus y1 squared. So BC, from B to C. Well, B is at negative 5.5 and C is at 2.5. So I'm going to go 2.5 minus a negative 5.5 squared plus, and it's 2 minus 13 squared. BC is going to be negative, and a negative make a positive. 2.5 plus 5.5 gives me 8 squared plus negative 2, or 2 minus 13 is a negative 11. So that's negative 11 squared. And I know when I do that, 8 squared is 64. 11 squared is 121. So I know that it's the square root of those two added together. So that should be the square root of 185. 185. Now I know 185 is not a perfect square. 169 and 196 for 13 and 14 respectfully. So I know that the square root of BC is 185. It's the square root of 185 for B to C, that distance. All right, so now we can find the perimeter for this. So I can simply take and add these up. So I'm going to add 10 plus the square root of 125 plus the square root of 185. And I can put all of that just that way into my calculator, because it does say that we can round to the nearest tenth. So I don't need to simplify these. I don't need to do anything. I can simply do the nearest tenth. So I can put in 10 plus the square root of 125 plus the square root of 185 into my calculator. Remember, you can find the square root on your calculator by hitting second and the x squared button. When you do that, you can get what you need for your calculator for the square root. So the perimeter is going to be 34.8 when I put that into my calculator. And remember, we are using units as our measurement, as our label as we do this. Now, the next question says, what information is needed about triangle ABC to determine the area? Well, I'm going to need the height. I need height. I need height to be able to do it. I need to know how tall this triangle is in order to do it. Now, it also says that Adam says that line segment AB can be used as the height. Tricia disagrees and says that BC can be used as the height. Randy disagrees with both of them and says that none of the line segment currently on the triangle can be used as the height. Who is correct? And explain your reasoning. Well, Randy is. And I want you to think about the room you're sitting in right now. You look at all the walls and they are perfectly perpendicular, meaning that they form a 90-degree angle at every corner. They're not slanted. If you look at AB and BC, both of those are slanted towards AC. They're not 90-degree angles at angle A and angle C. or angle B. There are no 90-degree angles anywhere inside that triangle. So Randy is right because the height must be perpendicular, right? Must be perpendicular to the base. Okay? It must be perpendicular to the base. And in this triangle, we're going to make AC our base. Why? Well, visually, it's at the bottom. It looks like a floor. It looks like the ground, and we want to build the height straight off the ground. Okay? So, the next thing says, and I'm trying to keep the graph in here and not get too crazy, but it says, the next thing says, draw a line segment representing the height of triangle ABC and label it BD. Well, I'm giving you a big hint here. We're going to come out of the vertex B and come straight down to AC. Okay? So, here we go. Out of vertex B, straight down to there. Okay? This becomes my height. The other thing I know is that since I'm drawing it straight, that it is a straight line. And the reason why it's a straight line is that AC is a horizontal line. In this now BD, and I'm going to label it D. I'm going to change color so we can see it. This line BD is a vertical line. A vertical line and a horizontal line are always perpendicular when they intersect. So I know that this is a vertical line. Okay? So, determine the height of this. Well, I can simply count it. It's a vertical line. And I know that BD, line BD, that's line segment BD, is 11 units. And I know this by simply counting from B down to D. I'm counting from 13 down to 2. That is 11. Right? 13 minus 2 is 11. So I know my height is 11. It's countable because it's a vertical line. So now, determine the area of the triangle. So the area formula, remember, is 1/2 times the base times the height. So that is area equals 1/2 times. My base was 10. Remember, AC is 10. And my height is 11. So I know that area is equal to 1/2 times 10 times 11, or 55 units. Now, remember, area is always units squared. So my label is units squared. All right. Let's do the next one. Turn the page. Here we go. It says, let me get there. It says graph triangle ABC with vertices at A at 2,5, B at 10,9, and C at 6,1. Now this one's going to be more difficult and you really are going to need to pay attention. You may need to pause at times, get down what you need, and then start it again. Okay? So let's go ahead and graph this triangle. A is at 2, 5. 2, 5 right there. There's my A. B is at 10, 9. 10 all the way up to 9. Here's my B. There's my A. And C is at 6, 1. 6, 1. There's my C. Draw my lines between the vertices, meaning between A, B, and C. Draw the lines. And there is my triangle ABC. Now it says, determine the length of AC, which will be used as the base. Leave your answer in simplest radical form. So we want to determine the length of AC and leave our answer in simplest radical form. So we cannot count A to C because it's not a vertical line nor is it horizontal. So once again we must use the what? You got it. Distance formula. So AC is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. AC is equal to, now plug and go. I got a 8 to C, 5 minus 1 plus, hang on here, let me get the right points here, let me look at this. A is at 2, 5, C is at 6, 1, so I'm going to go 6 minus 2. Sorry about that, I was looking at the wrong point. And when I started at C at 6, I'm going to go 1 minus the 5. All right. AC equals then 6 minus 2 is 4. So that's 4 squared. And 1 minus 5 is a negative 4 squared. So AC equals the square root of 16 plus 16, or the square root of 32. Now, it does say leave your answers in simplest radical form, so I need to go ahead and reduce this. Well, the square root of 32 is going to break down to the square root of 16 times the square root of 2, or 4 square root of 2. So I know that AC is equal to 4 square root of 32. And I'm going to draw it like that and say that's the distance. I need some room there because I know what's coming. All right. The next thing says, how will determining the height of this triangle be different from determining the height in the last example? Well, in the last example, I had a horizontal line so I could draw a vertical line down to it. This time, AC is not a horizontal line, nor is it a vertical line, so I can't simply draw to it. So the height, in this case, the height will not be a vertical line, and thus we cannot simply count nor big word, nor draw it in. Okay? So we're going to have to do something mathematically to be able to find the height. We know that we still want the height to come out of vertex B because we want AC to be our base. Okay? So, and it's going to be hard to keep the graph on here as I do this. So you're going to see me scroll a whole lot. Okay? The next question, it says, remember that the height must be perpendicular to the base. Well, I've already said that. What do you know about perpendicular lines in the coordinate plane? Well, perpendicular lines, the slopes must be opposite reciprocals of each other. And remember, what that means is this, is that if I have something with a slope of 3 over 4, in order for it to be perpendicular to another line, the slope of the other line has to be a negative 4 over 3. That's what opposite reciprocals mean. Okay? That if I have one slope at 3/4, the line that's going to be perpendicular to it has to have a slope of negative 4 over 3. Okay? So what is the slope of base AC? Well, we can count it, or we can use the formula. I'm going to use the formula because I need you to be able to see it. Now, you can count rise over run, but the only problem with that sometimes is you're going to count the run in first and then count the rise second. And remember, that would be reversed of what you need. So I'm going to show you the formula as we do this. So, remember that the formula for slope, M is our slope. Remember, M is our label for slope. And that is y2 minus y1 all over x2 minus x1. And in this case, our y2 that we used earlier was a 6. Our y1 that we used earlier was a 2. Our x2 was a 1. And our x1 was a 5 that we just used in our distance formula. Remember, we just used that right up here. We just did that right there. So I'm just plugging those values in that I've already used. Makes it easier. And now I can simply, 6 minus 2 is 4. 1 minus 5 is negative 4. 4 divided by negative 4 is simply negative 1. So I know the slope of AC is negative 1. So the slope of AC equals negative 1. So what will be the slope of the height then? Well, the slope of the height, remember, it has to be the opposite sign, and the reciprocal means flip the fraction. Well, if you remember, a negative 1 as a fraction would be simply 1 over 1, or negative 1 over 1. So when I do this, what does the slope of the next one, or the height, have to be? Well, it has to be a positive 1 over 1, or simply just 1. That is the opposite reciprocal of negative 1, is simply positive 1. Okay? Now, it says, remember that the height must come from the vertex opposite the base. This is a big thing for you guys right here. It has to come from the vertex opposite the base. In this case, that means, and I'm going to do it in red, that means it has to come out of vertex B. Has to come out of B. And let me do it in a different color that you can see. Pink. We'll go pink. Pink. It's got to come out of B. Okay? So I'm going to continue to read. Which will be the point B in this problem? Okay, so start at point B and use the slope of the height to place the height of triangle ABC. Meaning that I'm going to use the slope of the line that I want to be the height to go from B down to AC. Now it says label the point where the height intersects the base point D. Identify the coordinates of point D. So here we go. And you're going to see me do it in this right here. So remember, it is a slope of 1, right? Well, I can't go up 1 and to the right 1, so I'm going to have to go down and to the left 1. You're going to see me draw it, okay? You're going to see me draw it as I do. So down 1, left 1. Oh, I don't want you to do that. So down 1, left 1, 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 and there's where I intersect right there. Now remember, I'm going down and to the left because my slope is a positive 1, and remember, 2 negatives make a positive. If I had gone down 1 and to the right, that would have been a negative slope. I want positive slope, so down and to the left, down and to the left, down and to the left until I got there. Now I'm going to connect those dots, and that is my height. That is my height. That line right there. Now I had that stairs in there because I want you to see it. So this becomes point D. Okay. Now BD is my height. So BD is now my height of triangle ABC. Okay. So let's keep going. It says determine the length of height BD. Leave your answers in simplest radical form. So, looking up here, I know that B is at 10, 9. So B is at the point 10, 9. And I know that D is at the point, where is it? It is up here at 4, 3. So my point D is at 4, 3. 4, 3. So now I'm going to use the distance formula to find it. So BD equals the square root of you're going to see me write it again. X2 minus X1 squared plus Y2 minus Y1 squared. So BD is equal to the square root of, let's plug in, X is 10 minus 4 squared plus 9 minus 3 squared. BD equals the square root of 6 squared plus 6 squared. So BD is equal to the square root of 36 plus the square root of 36, which is equal to the square root of 72. Now, simplest radical form. So the square root of 72 breaks down to the square root of 36 times the square root of 2, or 6 square root of 2. So I know that BD is 6 square root of 2. Okay? So now, last but not least of this, it says determine the area of the triangle. If necessary, leave answers in simplest radical form. So, area for this, remember, is 1/2 times base times height. So 1/2 times, our base distance was 4 square root of 32. So 4 square root of 32 times my height, which is 6 square, oh, come on now, square root of 32. And all of that can go into your calculator, as you can see. So, here we go. 1/2 times 4 square root of 2 times 6 square root of 2. When I put that into my calculator, and why did I say 32? It's just 2. Holy cow, Kevin. Hopefully someone caught that earlier, because I'm writing 32, and I'm saying, well, because I have 2 here, and I had 2 up. Oh, that's why. Remember, it was 2, Kevin. 2. Hopefully someone caught that. Right here, 4 square root of 2. Good catch, anybody that caught it before now. So 4 square root of 2 and 6 square root of 2. Well, remember, square root of 2 times square root of 2. Let's do this by hand real quick. So this is 1/2, so 0.5 times 4 times 6. And remember, the square root of 2 times the square root of 2. Well, what happens when you have the square root of 2 times the square root of 2? Well, you get just 2. Remember, the square root of pink pig times the square root of pink pig is a pink pig. So therefore, the radicals just cancel out. So that's done. I'm at 2 times 6 times 4 times 0.5. Well, 4 times 6 is 24. Times 2 is 48. Times half is 24. So I know that my area is simply 24 units squared. Now, all that could have gone in the calculator. You would have gotten the same thing. Okay, because it comes out nice and clean. All right, turn the page. I believe this is the last one. It is. Last one for this unit, or last one for this day. All right. Let's do a different color to start off with. It says graph triangle ABC with vertices at -14, 2, -4, 2, and -12, 5. Determine the area of the triangle. So remember, area is going to be 1/2 times base times height. So let's go. Let's graph this. -14, 2. -14, 2 goes right there. I don't want you to get too crazy, but right there. Now, B is at -4, 2. -4, 2. Oh, that's nice. That's an A, and that's a B. And C is at -12, 5. -12 and 5. About halfway between 4 and the 6. So this is C. So there. Draw that a little straighter. And to there. Now that's my triangle ABC. Now we want the area of this. Well, a couple things I see. First off, I see AB is a horizontal line. It's horizontal. Oh, I ran out of room there. Let me scoot this over. AB is a horizontal line. That's huge for us. Means it's countable. So from A to B should be 10, right? AB should be 10. Negative 14 to negative 4 is 10. So that's countable. Well, the next thing I know is that if I make AB my base, if AB is also my base, then my height can come out of vertex C, right? My height can be a vertical line. It can become a vertical line out of vertex C down to B. So when I do that and I see that, I can go out of C and go straight down to AB. And that is my height. So I'm going to make that D. I'm going to keep with that trend and make that point letter D. And so CD is countable as well. So from C at 5 down to 2, so CD is going to be 5 units. So CD is 5. Well, I have enough information to find the area of this. So area is equal to 1/2 times 10 times 5. Holy cow, Kevin. I saw another mistake. It's not 5. It was coming out of 5. Why am I making so many mistakes today? Probably because it's a Saturday. All right. The height from C to D. Oh my gosh. Should have been right there. And it's here is the height. And it's 5 minus 2, or CD is 3. 3. 3 is my height, not 5. It's coming out of the height of 5. Holy cow. And I still wrote 5 again. 3. Hopefully you keep pausing this and figuring out that I'm making mistakes and I'm not really there. I'll try to clean it up here. Oh my gosh, Kevin. 1/2 times 10 times 3. So this becomes 15 units squared. Alright. I'm just going to continue and see if I can not make another mistake. This is way too many, and they're not on purpose today. Brandon's teacher asked his class to double the area of triangle ABC by manipulating the pre-image. Brandon's new triangle is shown below. So remember, if I start with a triangle, if I start with an image, doesn't matter if it's a triangle, if it's a square, rectangle, whatever, the first image is called a pre-image. So first image, it is called a pre-image. The second one, after I make the change, the second image, which is after the change, is called the image. It is called the image. Okay? That's very important. So we'll talk about pre-image and image. What I start with is the pre. When I make my change, my transformation, my translation, my dilation, whatever I'm going to do to it, that is now called the image. So you can see the manipulation on this one. And what happened? Well, it looks like it got bigger. Because now C, and this is C prime. C prime is at 8. It's at negative 12, 8, which is increased by 3. So I know that my height as what? My height is now 6. It used to be 3, which I kept saying it was 5. It used to be 3, and now it's 6. 8 down to 2 is 6. Now, I also look at this, and what do I also notice? Well, I also know that the length of AB got bigger as well, because now A prime is completely further away than it used to be, and B prime is further away. And if I count now A prime, B prime, and that prime tick, that little tick mark above A, above C, and above B, is called A prime. And what that means is this is the image off of the preimage. When I make the manipulation, when I make the transformation, I'm going to acknowledge what I changed by the tick mark. And when I look at this, I now notice that A to B is now 20. So that has doubled as well. So determine the area of Brandon's triangle. Well, his triangle that he did is 1/2 times 20 times 6, which is going to be 60 units squared. Now, how does this relate to the preimage? Well, it's not double. What is it? It's 4 times bigger. And how do I know it's 4 times bigger? Well, because 15 times 4 is 60. So I know it's not double, because 15 times 2, or doubling, would be 30. I've quadrupled it. I've multiplied it by 4. Okay? Now, describe Brandon's error, and what should he do to draw a triangle that is double the area of the preimage? Well, his mistake is that he quadrupled it. He doubled both the height and base. He should have done simply, he should have just doubled one of them. He should have just doubled one of them, not both of them. Okay? So, let's do that now. So, here we go. Triangle ABC is given, the original one, and the one that looks like the one we did earlier, right? All the way at the top, these are still the ones that we did from the beginning. And it says triangle ABC is given. Double the area of the triangle by manipulating the height. Label the image and determine the area. All right. So, when I look at this, if I want to manipulate it, by manipulating the height. I want to double the area by changing the height. Well, I can do that. If my height was originally 3, I can make it 6 by taking C and making it C prime at 8. Instead of 5, it goes up to 8. And my height ends up being this. I don't have to change anything else, because if I change anything else, I start to now either triple it or quadruple it like in the last example. So all I'm going to do is draw my lines now, connect, because the only vertex I wanted to change was the C. Now notice that I created triangle A, B, and C prime, because I've manipulated that C, that vertex C. Original height was 3. The height now is 6. So the area of this now is going to be 1/2 times 10 times 6, or 1/2 times 10 times 6 is 30 units squared. All right, and last but not least, let's go that one. Now it says double the area of the triangle by manipulating the base. Label the image and determine the area. So I can take either A out or B out by doubling it, right? By going twice as far. So, or I could do both A and B out, 5 and 5, and get 10. I'm going to take A out 10. So I'm at negative 14, so I'm going to go all the way out here to negative 24. And I'm going to put A prime out here. When I do that, I'm going to go ahead and connect because I'm there. And I'm right there. Now once again, I already know my height, and I'm going to do it in a different color so you can see it. I know my height here. My original height was 3. Alright, we know that. We are now creating triangle A prime, B stayed the same, C stayed the same, so it's just A prime, B, C. Okay? Because I only manipulated vertex A. So my area is going to be 1/2 times my base. And my base, since I took it out another 10, my base is going to be 20. And my height is 3. And once again, 1/2 times 20 times 3 is 30 units squared. Alright, that concludes that day of notes. Make sure that you take them and understand them. Remember, you're getting 2 days of notes via video. Hopefully you're following along. Remember, pause, go back if you need it, anything you need to do. Alright, have a great day. See ya.